Assalamualaikum warahmatullahi wabarakatuh and good morning, respected lecturer and fellow classmates. My name is Nashaira binti Azizain. My matrix number is 2025422124. We are Group 1 and today we are presenting our IoT mini project entitled Rain Detector System using ESP8266 and Blink. Our project is designed to automatically detect rain using a rain sensor and provide real-time monitoring through the Blink mobile application. The system combines both hardware and IoT technology. It uses an ESP8266 nodes MCU as the main controller, a rain sensor to detect rainfall, a servo motor to simulate automatic window closing, LED indicators, a buzzer, and the Blink platform for remote monitoring and notifications. The main purpose of this project is to reduce the risk of rain damage by providing automatic responses and real-time alert. So now, I would like to invite Sophia to explain the problem statement. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sofia binti Muhammad Hazi and my student number is 2025215038. Next, I will explain the problem statement of our rain detector system. The first problem is unpredictable weather. Rain can occur suddenly without any warning. When clothes are left outside, they may become wet before the owner notices. This results in waste time, water, electricity, and detergent because the clothes need to be washed and dried again. The second problem is the difficulty in monitoring the weather. Many people are away from home during work or school, so they cannot bring their clothes inside immediately when it starts raining. In addition, weather forecasts are not always accurate, making it difficult to rely on them completely. The third problem is the lack of affordable automation. Monitoring the weather manually is inconvenient and requires constant attention. Although smart home systems are available, they are often expensive and not affordable for everyone. Therefore, there is a need for a simple, low cost, and automated rain detection system. Our rain detector system is designed to solve this problem by detecting rain automatically, providing alert through an LED and buzzer, and operating a servo motor without requiring manual intervention. Next, we move to the objective of our project. First, design and develop an Arduino-based rain detector system. Second, detect rainfall using a rain sensor. Third, activate buzzer and LED as alert. 4. Operate a servo motor automatically. 5. Improve user convenience. And lastly, reduce time and energy wastage.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nolia Nafika binti Muhammad Tua and my student ID number is 2025243564. I will explain the hardware components used in our rain detector system and how they work together to create an IoT based on automated system. Our project consists of a 6 main hardware components: the ESP8266 non-MCU, rain sensor module, servo motor, buzzer, LCD indicator, and Wi-Fi connection. The first and most important component is the ESP8266 non-MCU. This is the main controller or the brain of our system. Its job is to receive the data from the rain sensor, process the information, and control all the output devices. One of the reasons we choose the ESP8266 is to because it was built in Wi-Fi module, allowing it to connect directly to the internet without requiring additional hardware. This enables our system to communicate with the Blink cloud, allowing users to monitor the rain status remotely using their smartphone or the website. In our program, the ESP8266 read the rain sensor value every 1 second to process the data and control the servo motor, LED, buzzer, and they send the real-time data to the Blink application. The second component is the rain sensor module, which acts as the input device. Its function is to detect water droplets or rainfall. In addition, the sensor contains conductive lines on its surface. When water touches this line, the electrical resistance change the production different analog values, and these analog values are sent to the ESP8266 through the A0 analog pin. And in our project, we set the threshold value at 400. If the sensor reading is 400 or below, the system recognizes that rain has been detected. If the reading is above 400, the system indicates no rain. This allows the system to continuously monitor weather conditions in real time. Next is the servo motor, which acts as the automatic actuator. Unlike a normal DC motor, a servo motor can rotate to a specific angle. In our project, the servo motor simulated an automatic window. When there is no rain, the servo motor remains at 0 degrees and representing as an open window. When rain is detected, the ESP8266 send a control signal, causing the servo motor to rotate to 118 degrees, representing the window closing automatically. This demonstrated how IoT technology can automate everyday tasks without human intervention. The next component is the buzzer. The buzzer functions as an audio warning device. When rain is detected, the ESP8266 activates the buzzer to produce an alarm sound. This immediately alerts anyone nearby that rain has started. When the rain stops, the ESP8266 automatically turns the buzzer off. The buzzer provides an additional warning beside the smartphone notification or website notification. In addition, our system also uses two LEDs as visual indicators. The green LED indicates the normal condition. When there is no rain, the green LED remains on, showing that the system is operating normally. The red LED acts as a warning indicator. When rain detected, the red LED turns on while the green LED turns off. Using different color LED makes it easy for users to identify the current system status immediately. Another important component is the Wi-Fi connection. The ESP8266 connect to the internet using the Wi-Fi SSID and password program into the system. Once connected, it communicates with the Blink Cloud platform. Every second, the ESP8266 sends the ring percentage to the couch widget. The widget or the website updates the ring status on the label widget, controls the LED widget, and sends a push notification whenever ring is detected. This allows users to monitor the system remotely from anywhere using their smartphone or their websites. Now, I will explain how all the hardware components work together. The process begins when the ring sensor detected water on its surface. It sends the analog reading to the ESP8266 MCU. The ESP8266 processes the sensor value and compares it with the preset threshold. If the value indicates rain, the red LED turns on. The green LED turns off, the device sounds, the servo motor rotates to 118 degrees to simulate closing a window. At the same time, the ESP8266 sends the ring percentage and status to the Blink Cloud. Finally, the user receives a real-time notification and on the Blink application. When the ring stops, the ESP8266 automatically resets the system. The green LED turns back on, the buzzer stops, the server returns to 0 degrees, and the Blink application updates the status to the no ring. Over data flow, the complete data flow of our system is ring sensor to ESP8266 non-MCU, to decision making to servo motor plus LEDs plus buzzer, to Wi-Fi Blink to smartphone. This shows how our project integrates input device data processing, automation, cloud communication, and remote monitoring into one complete IoT system. Thank you. That is all for the hardware explanation. I will now proceed to the project demonstration.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazmira Izzati bin Yasmi. My metric number 2025236032. In conclusion, our rain detector system successfully combines sensing, automation, and IoT technology into one complete system. The rain sensor detects rainfall, the ESP8266 processes the information, the LEDs and buzzer provide local warning. The servo motor perform an automatic action, and the Blink application enables users to monitor the system remotely. The system also sends real-time push notification, making it practical for daily use. For future improvement, we plan to add weather forecasting APIs, waterproof housing, battery backup, and data logging for rainfall history. Overall, this project demonstrates how IoT technology can improve convenience, automation, and safety in everyday life. Thank you for your attention.
I just had to let you know you're